Welcome back. Now I want to show you the effect of antioxidants on free radicals. Before we go on, I want to give you some examples of free radicals. We have some examples from the what I posted already on the board. We have examples like hydrogen peroxide is a free radical. The formula of hydrogen peroxide is H2O2. Hydrogen peroxide is a free radical. We have ozone. Ozone is O3. Why oxygen is O2? Ozone is O3. Then we have hydroxyl radical. Hydroxyl radical. Hydroxyl radical. Hydroxyl radical is OH minus with a superscription minus. That should be that should be L in that hydroxyl radical. And then we have super oxide, and the formula is 0 1 electron on top and minus. It's on the board if you have seen that video. So somebody might ask, what is the difference between ozone and oxygen? Ozone and oxygen, they are allotropes. Allotropes. People that study chemistry or people that know chemistry know what an allotropy is. Allotropy is the existence of a chemical element in two or more forms, which may differ in the arrangement of atoms in crystal solid. That is, in a physical form, the elements that is exist, element can exist. They are the same compound, but in a physical form, it can exist in more than two ways. So oxygen and ozone, oxygen is O2, ozone is O3. They are allotropes. Just like diamond and graphite, they are allotropes. They are the same carbon, but in a physical state, they appear differently, but the same chemical content. So ozone and oxygen are allotropes. And then we will look at from that board, the picture, we will use hydroxyl group as an example. Let us see how antioxidants helps to prevent all this problem. If you check the diagram on the board, the hydroxyl group, which is OH minus, has about 5 electrons, that is 6 electrons in the outermost shell. That oxygen has, because the atomic number of oxygen is 8. So while filling the electron in the valence shell, the innermost valence shell will take 2. So the 6 that are left will be on the valence shell. So when oxygen combines with hydrogen, it will hydrogen has 1 electron. Oxygen will bring out 1 electron, hydrogen will bring 1 electron, and they will share, and they will be left with 5 electrons on the valence shell of oxygen. And that valence shell, if you look at the diagram, you have two paired electrons and 1 unpaired electron. So according to our diagram, the antioxidant will supply 1 electron to that hydroxyl group. Instead of it now to be hydroxyl radical, which is unstable, it will receive 1 electron from antioxidants. And then if you take the diagram there, it will now be the number of electrons in the outermost shell of oxygen is now 8. If you check that diagram, which is now hydroxide ion, which is stable. So as far as this radical is in form of hydroxyl, that is OH minus, it is not stable. It can attack any organ in the body, because you want to get that deficient electron. But what antioxidant this antioxidant here, what was done here, it gave out one electron, so that instead of it being hydroxyl radical, it is now hydroxide ion. So, like I said, note also that selenium breaks down the hydrogen peroxide in the body, because the effect of hydrogen peroxide in the body is that it attacks DNA. But what selenium does, which is an antioxidant, will help to break that hydrogen peroxide. When it adds electron to it, it will break, and then it will no longer be in form of hydrogen peroxide, which is harmful to the body. So it will neutralize the effect. The summary is, like I told you, free radicals, they are unstable. They have free valence unpaired electron, and the electrons in the shell, they go in pairs. So whenever we have unpaired electron, that unpaired electron is looking for another electron to make it paired, that is double. And when it is looking for that electron, it will just be moving up and down in the body, attacking the system, looking for where to get that extra electron. But thank God, the antioxidants will always supply that electron, and everything will calm down. Can you now see the need for us to actually look for things that will boost our these are antioxidants in our body? Maybe through the food we eat, our lifestyle. I've told you how the free radicals can be gotten. So what we'll be looking for is to how to get rid of this free radicals, so that it will not be too many in our body. It will be there because everyday activities will generate it, but we don't want it to be too many. So that is the summary, the effect. The deficient valence electron in free radicals that is causing the problem, making it unreactive. Antioxidant will supply it so that it become stable, and the systems of the body will be spared. That is what it is. What do you think? If you find a get value from what I've said, go to the comment section, like the video, put your comment, ask questions, contribute your own, and then we carry from there. So let us get a feedback to know whether you are getting value from what I'm saying, or whether you're appreciating what I'm saying. Bye.